I'm going to go over a couple of the problems from Unit 2, Worksheet 2. We're going to start with number 4. So there's two parts to this. On the left side, part A, we have two functions. The first function, f of x, is equal to negative 1/2 absolute value of x plus 2 minus 1. And our second function is g of x equals negative 1. So we have the absolute value function, remember, makes a V shape. It's been translated from the parent graph point 0, 0, left 2 down 1. And the slope of the right hand side is the negative 1/2, which means from that vertex I drop down 1, right 2. And that gives the right side of your V shape. And then we could go down 1, left 2 to reflect that across the vertex, giving us that V shape. The g of x equals negative 1 is this line right here. So that's g of x. And this one's f of x. And part A is asking, when is f of x equal to g of x? At what x value do they touch each other? And I'll highlight that. It's right there. And that's happening at x equals negative 2. For part B, we're asked to solve algebraically for x when f of x is equal to g of x. So for f of x, we have to use the function that I highlighted in green. So I'm going to replace f of x with negative 1/2 absolute value x plus 2 minus 1. And that's equal to g of x. G of x is negative 1. When solving this, I'm going to first get that absolute value of x plus 2 by itself. So I need to get rid of the negative 1 on the left side and the negative 1/2 on the left side. I start by adding 1 to both sides of the equation. And then I'm going to multiply both sides by negative 2. When I multiply the negative 1/2 by negative 2, I end up with positive 1. When I multiply the 0 by negative 2, I end up with 0. So you get absolute value of x plus 2 equals 0. Well, if I told you that the absolute value of some number equaled 0, what number would that be? In this case, there's only one choice, so that tells us that x plus 2 has to be the number 0. So if I subtract 2 from both sides, I end up with x is negative 2. Notice that's the same exact answer we got when we graphed them individually and looked at where they crossed. And so this problem can be solved graphically and algebraically. Next, I'd like to look at number 6. Here we're asked to solve for the following absolute value equations for x and to graph the solutions on a number line. If there's no solution, then we write none and explain why. So here we have the composition of two functions. We're plugging g into the function f. So that notation means we get the absolute value of x plus 9. And that's equal to negative 11. When you take the absolute value of a number, you always get a positive answer. And so here we're going to say there's no solution to this, because the left side is always positive, no matter what x value you plug in, but the right side's negative. So the absolute value of a number will always be positive. Next, take a look at number 7. Here we first solve for the absolute value of 6 minus 3x. We want that part by itself, so we need to get rid of the fraction 1 over 7. If you ever are solving an equation, so something that has an equal sign, and you want to get rid of a fraction, you multiply both sides of that equation by the denominator. So if I multiply the left side by the denominator, 7, and I multiply the right side by 7, I end up with 7 over 7, because this is really a 7 over 1, and you multiply with a fraction, you numerator times numerator, denominator times denominator, times the absolute value of 6 minus 3x is equal to 21. And 7 over 7 is really 1, so this is just the absolute value of 6 minus 3x equals 21. Now if I told you I'm thinking of a number and the absolute value of that number is 21, well, what could it be? That number could be 21, so the 6 minus 3x could be 21, or the absolute value of negative 21 is also equal to positive 21, so that number could also be, the 6 minus 3x could also be negative 21. Both would give the solution of 21 when you take in the absolute value. So we have two equations in which we're going to come up with two answers. So subtract 6 from both sides. 21 minus 6 is 15. Divide by negative 3 and you get x is negative 5 for the first equation. Subtract 6 on the second equation, you get negative 27. Divide by negative 3, you get x is positive 9 for the second equation. So we have solved, but remember they ask us to graph this on the number line. The number line is just, you don't have your x and y axis, you just have that x-axis. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have a solution at 9, put a closed circle there, and we have a solution at negative 5. Closed circle there. So that's how you would graph your solution set here. Next, let's take a look at 13. 13 has that expression f of g of x, which again can be represented this way, f of g of x. It just means take g of x, plug it in for x in the function f. And so that would be the absolute value of 3x minus 6. So we're going to use that in this equation. So the equation is 7 minus 3 times that whole thing. Okay, that whole thing is the absolute value of 3x minus 6 is equal to negative 14. Once we have it written that way, we want to solve for the absolute value of 3x minus 6. We want that by itself. So be careful here. Do not subtract 7 and 3 because we have to follow order of operations. This is 3 times the absolute value, and you have to multiply before you subtract. So instead, what we're going to do is subtract 7 from both sides of the equation. That we're allowed to do. We end up with negative 3 times the absolute value of 3x minus 6 is equal to negative 21. Second, divide both sides by negative 3, and we get the absolute value of 3x minus 6 is equal to positive 7. Now we know that the absolute value of 7 equals 7, and also the absolute value of negative 7 is equal to 7. So that 3x minus 6 could be either of those two values. It could be a positive 7, or 3x minus 6 could also be a negative 7. Both would produce the absolute value equal to 7. On the first equation, we add 6 and we get 3x is equal to 13. Divide by 3 and you get 13 over 3. Leave it as a fraction. Second equation, you add 6 to both sides, getting 3x equals negative 1. Divide by 3 to get x is negative 1/3. If we think of the decimal values of these, 13 over 3 is just rounding. Well, 3 goes into 13 4 times. You have a little left over. You have a third left over, which would be 0.3 repeating, right? So on. Whereas negative 1/3 is negative 0.3 repeating. So if we put that on a number line, one's going to be between 4 and 5, and the other one's going to be between 0 and negative 1. So there's your negative 1/3, about right there. And your 4 1/3 is about right there. And that's all I'm going to do on this worksheet.